Let us look at proposition number 12 of Works of Archimedes. More specifically, book 1 of On the Sphere and Cylinder. The proposition says, if at the extremities of two generators of any right cylinder, tangents be drawn to the circular bases in the planes of those bases respectively, and if the pairs of tangents meet, the parallelograms formed by each generator and the two corresponding tangents respectively are together greater than the included portion of the surface of the cylinder between the two generators. So what this basically means is that we have a right cylinder and we have two generators AD and BC. What is a generator? It's in this case, it is a line which when we rotate it around the circle, it will form the cylinder. So we have two generators. Their extremities are A and D, B and C. So from these extremities, if we draw tangents in their respective planes, then we will end up with AE and BE in this plane and DF and CF in the plane of this circle. Now these tangents, they will meet at E and F. So when we join EF, what we end up with is two parallelograms, AEFD and BEFC. What the proposition is saying is that the sum of the areas of these two parallelograms will be greater than the curved surface of the cylinder included between these two parallelograms. So now we have to prove that. What do we have to prove? That parallelogram AEFD plus parallelogram BFC is greater than the lateral surface of the cylinder AGBCJD. I have not put in G and J. It will come. Now, what we'll do is we will bisect. See, remember, it is difficult to figure out the area of a curved surface. So now, how do we at least do some approximation? For that, what we do is we circumscribe a solid around this cylinder. We don't have to do it the complete cylinder. We just have to circumscribe a solid on this section of the cylinder. So let me do that. So I have set up the solid. Triangle AEB is greater than the segment AGB. Why? Because they both have the same extremity, that is line AB. And the segment is included in this triangle. Similarly, triangle CFD is greater than the segment CJD. Again, they have the same extremity CD and one is included in the other. Now, adding both of these up, we can say triangle AEB plus triangle CFD is greater than segments AGB plus CJD. Now, surface of parallelogram AEFD plus BEFC plus triangle AEB plus triangle CFD. So when we add up all this, we end up with this entire solid is greater than AKMD plus KHLM plus BHLC plus the top and bottom, that is AKHB plus CLMD. Why? Because again the extremities are same and one is included in the other. And here the extremity is the parallelogram ABCD. And let's say they differ by or this is greater than this by W, by a magnitude W. Now, surface AKMD plus KHLM plus BHLC plus AKHB plus CLMD, this solid, is greater than the lateral surface of the cylinder AGBC JD plus top and bottom, that is circular segment AGB plus the circular segment CJD. And let's say the difference between these areas is X. Now subtracting top and bottom. So we end up with AKMD plus KHLM plus BHLC and whatever is the excess that is there, that is X, is greater than the surface of the cylinder AGB CJD. The top and bottom has been subtracted. Now we have W, we have X. There are two cases. W is either greater or less than X. So let's take the first case where W is greater than X. Now in this case, AKMD plus KHLM plus BHLC plus W. W is what? The total, the difference between the total solid and this solid is going to be much, much greater than the surface of the cylinder AGB CJD. Why? Because here X is very small compared to W. And AKMD, KHLM plus BHLC plus X is greater than surface of the cylinder. So which means if we substitute X with W, it is going to be much more larger. Which means parallelogram AEFD plus BEFC is going to be greater than the lateral surface of the cylinder AGB CJD. Why? Because we have already shown that triangle AEB, top and bottom, AEB and CFD is greater than the segment AGB plus CJD. Now, what happens when W is less than X? This case, we do a much better approximation of the surface of the cylinder. We circumscribe a polygon with more sides on the sector AGB and construct the solid on it so that W becomes greater than X. So we have drawn a better approximation to the surface area of the cylinder. Now, like above, we go through it. Surface ARSD plus RQTS plus QPUT plus POVU plus BOVC plus the top and bottom, that is ARQPOB polygon plus DSTUVC polygon. The sum of this will be greater than the surface of the cylinder ABCD plus segments of the circles top and bottom. So again, we subtract the segments of the circles so that we end up with surface ARSD plus RQTS plus QPUT plus POVU plus BOVC plus X. Now here the X is the difference between the surface area of the polygonal solid and the cylindrical surface area or the lateral surface area of the section of the cylinder. So remember, W, we made it as greater than X. So which means if we substitute X with W, then this area will become much more greater than the surface of cylinder ABCD. What is this? ARSD plus RQTS plus QPUT POU plus BOVC plus W. That is nothing but our solid, the entire solid. So which means surface of the parallelogram AEFD plus parallelogram BFC is greater than surface of cylinder ABC. Because we have already shown that the triangle AEB plus triangle CFD is greater than the segments AGB plus CJD. So that is proposition number 12 of works of Archimedes, specifically book 1 of on the sphere and cylinder. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.